This time we are going to discuss the gate called negative AND. This is nothing else, just the AND gate with two or more inputs, with the negative indicators. These two negative indicators are nothing else, just two inverters. So A, B, and this is output X. This is AND gate with two inverters. This gate is called negative AND gate. You can redraw it and simply have something like this with two inverters and AND gate. This is called negative AND. A, B, X. Next, we're supposed to find the truth table of this gate. Okay, so because at this moment I have two inputs, I'm going to have four combinations. A, B, I have 0, 0, 0, 1, 1, 0, 1, 1. This is my output. And let's take a look at this diagram, because this one is going to basically allow us to look at the whole analysis in a very simple way. Okay, so I have, let's say if I apply 0, 0, 0, 0, this combination to both inputs, I'm going to have high, high at the outputs of the inverters. Remember, inverter is going to simply find the complement of the input. When both highs are going to be applied to the AND gate, output is going to be high. Okay, that's why I'm going to write high over here. If I'm going to have input A connected to 1, I'm going to apply 1 to A. If you are going to find the complement of 1, this is going to be 0. Remember, AND gate is the multiplication, so 0 times 1 gives me 0. So the output is going to be 0. Now I'm going to apply next combination. A is 0, B is 1. If you are going to find the complement of 0, this is 1, and complement of 1 is 0. 1 times 0, because AND gate is the multiplication, is going to give me 0. That's why I have 0 over here. And if I'm going to apply highs to the input of the negative AND, okay, at the output of the inverters, I'm going to have 0 and 0. 0 times 0 gives me 0. So this is the truth table for the negative AND gate. But let's take a look. We saw this truth table somewhere already, right? Now, I hope that you remember that this is the truth table of the NOR gate. Okay, let me just write over here. This is negative AND. And we found that NOR gate has exactly the same truth table. Okay, we have 0, 0, 0, 1, 1, 0, 1, 1, and I have 1, 0, 0, 0. So what we can say? We can say that the negative AND gate is equivalent to the NOR gate. Okay, so I have A, B. Okay, so these two bubbles are telling me that I have two active low inputs. Anytime I have no bubble means there is active high. In this case we have output. This gate has two active high inputs because I have no bubbles and active low output. They are going to perform exactly the same operations, but we're going to use them depends from the application. Some applications are going to require to use NOR gate, and some of them are going to require negative AND gates. We're going to talk about this in the next lessons. If it comes to the logic expressions, we have to look again at this diagram. Okay, I have two inverters and AND gate. So at the output of the inverter, I'm going to have A node, and at the output of this inverter, I'm going to have B node. And if I'm going to multiply these two expressions, I'm going to have A node, B node. We have learned that the logic expression for the NOR gate is A NOR B. And as you can see, the truth tables are the same, are identical. That's why I can write that A node times B node is equivalent to A NOR B. Okay, so let's do the problem.